Welcome to Metaminds Academy. This is a lecture series on matrices. This is lecture number 6 in the series. In this video, we are going to learn Gauss-Jordan method to find the inverse of a matrix. Also going to learn how to find the inverse using scientific calci. Here, the Gauss-Jordan method tells us that those elementary row operations or row transformations which reduce a given matrix A to the identity matrix I when same transformations are applied to unit matrix will give the inverse of A. That means what? Whatever operations that you are applying on A, you apply the same operations on I, row operations. Okay. Then A will be converted to the identity matrix and the identity matrix will be converted to A inverse. That is the concept of Gauss-Jordan method to find the inverse. Now this is the working rule. What we have to do is you write the two matrices A and I side by side. Then perform the same row operations on both A and I. As soon as A is reduced to I, the other matrix I will be reduced to A inverse. You write the answer A inverse. Now let us take this problem. A is given as 1, 1, 3, 1, 3, minus 3 and minus 2, minus 4, minus 4. So using Gauss-Jordan method, we are going to find the inverse of this matrix. Okay. So according to the method, what we have to do is we need to consider the two matrices A and the identity matrix I side by side. You write and make a separation. If you want to make a separation, you can. That means the matrix A 1, 1, 3, 1, 3, minus 3 and minus 2, minus 4, minus 4. And after a separation, you write 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, we need to convert this first matrix A into an identity matrix. So, how to convert? That means we have to get ones on the principal diagonal and the remaining entries must become 0. Okay. So, how to make these? First of all, we convert these two entries into 0. In the next step, we convert this and this entry into 0. And the next step, we convert these two entries into 0. Right. Now, how to get 0 here? R2. That means we are going to modify R2. R2 implies R2 minus R1. Okay. So, what we are going to get is, we are not going to make changes to the first row. So, I write the first row as it is. 1, 0, 0. Then R2 minus R1, subtract R1 from R2 and write it in R2. That means 1 minus 1, 0. 3 minus 1, 2. Minus 3 minus 3, minus 6. 0 minus 1, minus 1. 1 minus 0, 1. 0 minus 0, 0. So here we have to perform the same row operation on identity matrix also. You should remember that. Okay. Then how to get 0 in this place? That means we have to modify R3. So R3 implies R3 plus 2R1. We have to use first row only. Right? Because we are modifying R2, we should not use R2 to modify R3. In the same step, we are also modifying R2, right? So, to modify R3, we have to use R1 only, right? So, minus 2 plus 2 into this 0. Minus 4 plus 2 into 1 is 2. Minus 4 plus 2, minus 2. Minus 4 plus 2 into 3, 6. Minus 4 plus 6, 2. And this plus 2 into this, 2 into 1, 2. 0 plus 2 into 0, 0. 1 plus 2 into 0, 1. Now, the next step is we have to write now. Hmm. Okay. So in the next step, what we need to do is in this position, in the next step, what we have to do is in this position and this position, we have to get 0 based on this value. That means R2. So we have to use R2 to modify R1 and R3. So how to get 0 here? Based using 2, it is R2. We are going to modify R1 like R2 minus 2R1. 2 minus 2 into 1, 2. 2 minus 2, 0. Right? And the next one is R3. We're going to modify R3. R3 plus R2. Minus 2 plus 2, 0. R3 plus R2. Okay. So if you apply these two operations, what we are going to get is we will get minus 2, 0, minus 12, minus 3, 1, 0, 0, 2, minus 6, minus 1, 1, 0, and 0, 0, minus 4, 1, 1, 1. So this is what we are going to get after these two operations. So next target is to get zeros in these two positions. right? Because we need to get the identity matrix here. So how to get 0 here? Using R3, we have to modify R1 and R2. So multiply R3 by 3, you will get minus 12. Minus 12 plus minus 12. Minus 12 plus 12 becomes 0. You have to subtract. So modify R3, sorry, R1. You're going to modify R1 like a 3R3 minus R1. Right? Now first let us do it. So how to do? 3R3 minus R1 is 2. 3 into this minus this is 0. 3 into this minus this is 0. 3 into this minus this. 3 plus 3, 6. 3 into this minus this is 2. 3 into this minus this is 3. Next, we need to get 0 in this position in place of minus 6, right? So need to modify R2. So how to modify, how to get 0 here? Using this one only. You multiply R3 by 3, you will get minus 12. So how to get minus 12 here? It is 2, multiply it by 2. So minus 2R2. So 3R3 minus 2R2. 3 into this minus 2 into this, 0. 3 into this minus 2 into this is minus 4. 3 into this minus 12 minus 2 plus 12, 0. 3 into this minus 2 into this. 3 into this is 3. Minus of minus 2 plus 5. 3 into this plus 2. 3 into this minus 2 into this, 1. 3 into this minus 2 into this is 3. Next. And we are not going to modify R3, right? Minus 4, 1, 1, 1. Now the process is almost over because we need to get identity matrix here. We already got the 1, 2, 3, 4, 5, 6 zeros are there. Except the principal diagonal elements, all the elements are, other elements are zeros. Now how to get 1 on the principal diagonal? You just divide R1 by 2. R1, you divide it by 2. Divide R2 by minus 4. And divide R3 by minus 4. So 1, 0, 0. You are dividing it row R1 by 2, right? So 3, 1, 3 by 2. Dividing R2 by minus 4, 0, 1, 0, minus 5 by 4, minus 1 by 4, minus 3 by 4. Dividing R3 by minus 4, 0, 0, 1, minus 1 by 4, minus 1 by 4, minus 1 by 4. This is what we are getting. Now this is nothing but the identity matrix, right? We have got the first matrix is A is reduced to identity. And the second one must be A inverse. This is A inverse. Okay. So therefore the answer is, we have to express the answer finally. The answer is 3, 1, 3 by 2, minus 5 by 4, minus 1 by 4, minus 3 by 4, minus 1 by 4, minus 1 by 4, and minus 1 by 4. So this is the answer. Slide. We are going to find the inverse of the matrix, given matrix, using calci. So the better thing is to find the inverse in the beginning itself. Once you are given the problem using scientific calci, you can find the inverse in calci itself and write the answer somewhere and the answer sheet in the rough sheet. And so if you have answer with you, you can cross check whether you are doing the problem correctly or not. You can cross check, right? This helps. So let us know how to find the inverse in Calci. If Calci is allowed into your examination hall, you can find the inverse of the given matrix using Calci itself. So press mode, matrix is in 6, press 6, matrix A, select matrix A, matrix order is 3 by 3, it is in 1. Now it is a 3 by 3 matrix center. What we have just found the matrix inverse is, the matrix that we have just dealt is 1 equal to 1 equal to 3. So if you press equal to, that value will be stored in that particular cell. So 1, 3, minus 3, minus 2, minus 4, minus 4. So this is the matrix, right? Now press AC, shift 4, you press shift plus 4. In 3 you have matrix A, right? Matrix A is in 3, press 3. We have selected the matrix A. You have X inverse here, you press it, you will get matrix A inverse. Press equal to, you will get the inverse of the given matrix. 3, 1. Here you see 3 by 2 is minus 5 by 4, minus 1 by 4, minus 3 by 4, like that. You will get the inverse of the given matrix. And that is the end of lecture 6 on matrices. Please subscribe, like the video, share it with your friends and classmates, comment your feedback. Thank you so much. See you in the next video. Thank you.